Hello, welcome to another video. Here our topic is decision tree modeling using R programming. And there are different ways of using machine learning, such as you can use like many programs like Python or R is also quite popular. So here they mention decision tree modeling using R, and in my opinion, so I think using R can be easier to conduct statistic analysis, but I think there are more resources by using Python because there are more people are interested in. But I think by using R there are limited. That's why there are limited ways of demonstrating it. So but I prefer Python to apply machine learning modeling. So by combining both of them, for example, if you have no one to check if your analysis is correct, so you can learn how to apply machine learning by using R and also Python, and you can use both of them and you can compare the results. And I think the results will not be likely to be same, but results should be similar. Like if it's 73, then the other result must be like close to that, not like 40. And if the other result is not really fitting, then you should find better. You should rest study about it. So that's why it is important, and it's not easy to find someone to check your work. So here they claim that machine learning field decision tree learner is powerful and easy to interpret. It employs recursive binary partitioning algorithm that splits the sample in partitioning variable with the strongest association with the response variable. Here they introduce R functions to perform, not they actually, there is only one author, R functions to perform model-based recursive partitioning. I'm sorry for the bad pronunciation. This method incorporates recursive partitioning into conventional parametric model building. So they really like the word that I cannot really successfully pronounce. So the journal name is somehow it's like medicine journal. Decision tree learner is a technique of machine learning. As its name implies, the prediction or classification of outcomes is made going from root to leaves. The tree is made of decision nodes, branches, and leaf nodes. So here they include an example here. We use the air quality, so this air quality sample is quite popular for our practices. We obtain dataset and examine the data frame with the following codes here, and this result, there are 6 variables, and so these are the variables 1, 2, 3, 4, 5, 6 as you see, and one of them must be the target variable. The data frame contains 156 observations as you see here, and 6 variables here for 6. In the example we will set the ozone as response variable, so the variable that we want to use as a response variable. There are missing values in ozone because dropping observation results in information loss. The sample function allows taking a sample of specified size from given elements, and the given element is a vector containing non-missing ozone values. So the sample function that mentioned here. So from the output of some summary function, it is apparent that ozone contains no missing value anymore. So then probably the summary is also changed. We check the summary before applying it, and that there is that function like it, NA means like that non-missing variables. In this section we will use the inputted datasets to build a conditional inference tree owning to the C-tree function in party package. The code of building a tree is fairly simple. So the C-tree function created a conditional inference tree and returned an object of class binary tree class. The first argument of the function is formally defining the response, and so that there are the response and the input variables. The format of the equation is similar to that used in building generalized linear model. Data argument defines the data frame which the model is built upon. Okay, so I think, and later they see the decision, how the decision tree looks like. So here we can see the decision tree, and this wind is, they are variable, as you remember, temperature and wind. Here we see wind, temperature, and split statistic can be derived from split statistics element of a split. The following syntax draws scatter plots of split statistic for inner nodes 1, 2, 4, 7. The leaf nodes have no split statistic because they do not split anymore. Okay, so here this is the prediction code, I guess. It's similar to the Python code, and so I think we should be able to see the prediction number at the end of this. So I think the coefficients are very important too, and we should include coefficients in our study. And this is the final conclusion. Finally, I introduce R functions to perform model-based recursive partitioning. This method incorporates recursive partitioning into conventional parametric model building. Okay, that is quite interesting, and there is the biography of the author. And thanks for watching this video. I wish you enjoy it, and I wish you can apply this. And this is actually not a helpful example, because you should be able to copy from the article, but you cannot even copy. And I suggest you to watch at least 1 or 2 YouTube videos and also read articles that allows you to copy the code and paste. And if you have encountered any problems, then you can ask communities to solve the problems. Thanks for watching this video. Have a beautiful day. Bye bye.